Welcome to Fabric and Bits. My name is Brian Rutherford and I am the CTO, educator and a data engineer here at IO Analytics. This short talk is called Moving from SQL to PySpark, and it's really designed for data analysts and data engineers who are, like me, used to using SQL and have been using it for a number of years, but are wanting now to use PySpark in Microsoft Fabric. We're going to look then in this short talk at three things. First of all, what is PySpark? We'll then look at the common components that you may be familiar with from your use of SQL. The first of these would be cursors. And then thirdly, we'll look at the common clauses that you understand from your select statements, like select from, etc., and how these correspond with the PySpark code itself. So the first question really is, what is PySpark? PySpark is a coding language based on Python. It's used in Microsoft Fabric to allow data analysts and engineers to manipulate data, typically the data held in the tables and files area of a lakehouse. It's written in notebooks and can either be run manually or scheduled. And the processing of PySpark commands is handled by Apache Spark, the compute engine that underpins the Fabric Lakehouse. So what do I mean by these 4 points? I mean it's like a coding language, so it's got all of the programmatic elements that you might expect from that, such as loops, etc. It's used by Fabric to let you go in and actually pull data from and write data back to the tables and files area. And it's got its own interface, very much like the interfaces you are familiar with from using things like SQL Server Management Studio, like the worksheet, or using SQL Developer from Oracle, where you can type in your code, you can select that code, and you can then go and run it. And the Apache Spark compute engine is the processing engine that's running that code for you. So in a database management system like Oracle or SQL Server, it's the DBMS that does that for you. In Microsoft Fabric, it's the Spark compute engine that's running that code. If you're using PySpark, you are writing Python code, sure, but it's got a Spark-specific set of rules and protocols that let you interface with the data. So the Spark engine is allowing you to interface with it using this PySpark code to then go in and communicate with it to say, pull this data from here, process it in some kind of way, and then write it back to over here. And the last point is an important one, and that is that because PySpark uses Python, it means you have access to a rich ecosystem of libraries and functionality that you wouldn't get just with SQL. For example, you can import in libraries that would let you parse a PDF, take that data out of the PDF in a structured way, and then form, let's say, a table that can then be written to the Microsoft Fabric tables area. You don't get that kind of functionality with just SQL. Okay, if that's an overview of PySpark, let's look at the first of our common components that you may be familiar with, and these are cursors. So you may have been using SQL for quite a few years and been unaware of this, but when you actually run your SQL statement, what the DBMS does is it creates a virtual table in memory called a cursor, and that is short for a current set of records. And then when you are viewing that data, it's the cursor that you're actually viewing. Typically what happens is you can use the programmatic tools that come with that version of SQL to go in and to extract the first row from that cursor and then process it in some way, extract the second row, the third row, and so on. And that is typically done using some kind of function which is provided by the DBMS, and also a loop which is part of that programmatic set of code that you can use to go and process your data. And that's typically what happens, in fact, in data processing. As you might imagine then, if that's the so-called implicit cursor, you'll also get an explicit cursor as well. And what this is really is when you name the cursor, you say, right, I'm going to create this virtual table in memory that I want to use for processing. So could you create the cursor XYZ as, let's say, select star from employees? That will then create that cursor, and you can then go in and you can pop off the first row, process it, the second row, and so on, using some kind of a combination of function calls and a loop. If you understand that, then to move into the idea of data frames is easy, because a data frame is just another form of a cursor, a current set of records. And like a cursor, what you can do is you can give it a name. So typically what you might do is you would declare it in your code. So you've got here the cursor, the data frame, I should say, called XYZ. I'm saying then, right, fine, run using the Spark compute engine, the following command, pull back the following table and hold that data in the data frame called XYZ. And in much the same way, you can then go in and manipulate the data in that data frame in much the same way that you manipulated the data in your cursor. Data frames are actually a lot more powerful. You can do a lot more with that. But that effectively is the structure that is the corresponding structure that you may be familiar with from your use of SQL. If you don't know it as a cursor, it's called a data frame in Microsoft Fabric. One final point to make, just in passing, and that is that when you actually create a cursor, either in your DBMS or in Fabric, it actually creates a structure that doesn't have the data in it just yet. And when you call upon the data, that's when it actually begins to go and populate it. And that's particularly true for the data frame, where it uses a particular process called lazy evaluation. So the data frame actually at first is empty, it's a structure, but then when you call upon the data, it begins to bring in the data. Okay, if that is the first of our components that we understand from SQL, and we can translate that across into PySpark and understanding how that works, let's look at the next set of components, and that really is going to be the typical select statement. Here we have then a select statement. I'll give you a chance to go and look through that for just a couple of seconds. And as such, it's got, as you might imagine, a from, saying from the following tables, could you join from this table to the next, and so on. It's got a select area. It's got an area for summing up our columns. We know then if we are using that sum function in our select, we have to then use a group by to handle all of the columns and expressions out with the group functions. And finally, we have our order by at the end to go and order that data in ascending order by date, name, and employee. So that's a typical select statement. What does that look like in PySpark? Well, here's the statement just here. Again, I'll give you a chance to go and press the pause if you want to, and just take a look at that for a moment or two. Okay, to understand this PySpark code, you have to understand that unlike SQL, where the cursor was an element that you might have declared as part of your processing, or you might have just left it and just selected the data and had that implicit cursor, here in PySpark, it's all about data frames. That's really the component that holds the data as you work your way down from top to bottom, and as such, you can then begin to manipulate that data in these data frames. And in our case, we have three data frames, first of all. So we're pulling back our fact sale, dimension date, and dimension employee tables, and we're placing them into the data frames called FS, DD, and DE. Think of these as being three virtual tables that are sitting there in memory, and then tell the Apache Spark Compute Engine, could you go and join that data together from those three data frames? So in much the same way you might join three tables together, you can do the same thing with these three data frames and place that data into another data frame called joined DF. Okay, next step. I want to take that data in my joined version. I want to work upon it and aggregate it and take the results of that, place that into this other data frame called sale by date employee. So there's my reference there saying, right, take the contents of join DF, could you group by, could you sum it, then place the results into another new data frame called sale by date employee. And then finally, could you then go in and could you order the results to sort it? So take the contents of sale by date employee, order it by date, name, and employee in ascending order. And once you've ordered it, could you then overwrite the old version of sale by date employee with this new version? So this is an interesting idea, one that you will probably come across quite a lot in your PySpark code, is you can take a data frame work upon it, and then overwrite that same named data frame with its new version. So this really leads us to the idea that we have our from in our understanding of our SQL. We've got a join on component. We've got a group by. We've got a sum to go and aggregate that data. And we've got as well an order by at the end to go and order that data. And then finally, we also have an important element. Unlike SQL, when you run that code and it gives you the output straight away, you have to tell PySpark, yep, can take the contents of this data frame, can you actually output it? And I guess the reason for that is because there's more than one data frame now in this code. I could have said, could you output FS or DD or DE? Thanks so much for your time. We are Microsoft partners, and we run a 3-day course on Fabric to help you prepare for the DP 700 exam. If you're interested in that course, please do get in touch. The address is inquiries@ioanalytics.co.uk. Thank you.